Welcome to Math 8, College Algebra. Here are the solutions to homework set 1. So the first questions came from chapter 0 on page 67. First question is number 50. And we want to find out what's the cubed root of 54x cubed. And what a cubed root means is you're looking for three factors that are the same, and you can take them out of the cubed root. So what we need to do is factor 54 into some numbers that we know the cube root of. For example, 54 is 27 times 2. Okay, and I can figure out what the cube root of 27 is. The cube root of 27 is 3, because 3 times 3 times 3 is 27. So just note the cubed root of 27 is 3, because 3 times 3 times 3 is 27. And the cubed root of x cubed is x, because x times x times x is x cubed. So anytime you have a term that is a perfect cube, then we can take that out of a cubed root. Okay, so the 27 will come out as 3, and x cubed comes out as x. And what's left under the cubed root is just 2. So 3x times the cubed root of 2 is the final answer. For question 58, we have an exponent question. 4 to the power of 1/3 times 4 to the power of 5/3. Okay, when you have two exponents with the same base multiplied, two powers, you can add their exponents. So we'll add 1/3 and 5/3, keep the base the same. So when you have a common denominator, we can keep the denominator the same and just add the numerators. 1 plus 5 is 6. And 6 divided by 3 is 2. So 4 to the power of 2 is 16. For question number 66, we want to expand and simplify. So the question is given as 2x x plus 1 plus 3x squared minus x. So we're going to expand into the brackets in both cases, giving 2x squared plus 2x and 3x squared minus 3x. So now combine your like terms. 2x minus 3x is negative x, and 2x squared plus 3x squared is 5x squared. So there's the final answer, 5x squared minus x. Some of you factored and wrote this as 5x times x minus 1, and that's also correct. Question 70. Same thing. We want to expand x minus 2 times x squared plus 6x plus 9. So we want to take these two terms that are in the first bracket and combine them in every possible way with the three terms that are in the second bracket. So first we'll put the x in, and then we'll put the negative 2 into the second bracket. So when we multiply x, all the powers of x increase. Instead of x squared, we have x cubed. Instead of 6x, we have 6x squared. Instead of 9, we have 9x. Then when we put negative 2 in, we get negative 2x squared minus 12x minus 18. So just remember that you can think of this number here as negative 2. We want to multiply the negative 2 into the brackets. So now we're going to look for things that are in common. We've got positive 6x squared and negative 2x squared. We've got just one single x cubed, so that guy will stay by himself. 6 minus 2 is 4. Then we have 9 minus 12, which is negative 3x, and 18 is left by himself at the end. So there's the 4 terms in the final answer. Question 80. This time we want to factor. A factor is exactly the opposite of expanding. So some strategies for factoring are you want to try to find a number that all 3 of these terms have in common. So we've got 1, 2, 3 different terms. And all of them can be divided by the number 3. So we're going to take the number 3 and we'll take it out of the brackets. Then we want to see if there's any variable that they all have in common. Well, they all have at least one x, so we'll take an x out of the brackets. And then inside your brackets, you're going to write what's left over when you divide. So after we divide 3x squared by 3x, we're only left with negative x. After we divide negative 6x by 3x, we're left with negative 2. And when we divide 3x cubed by 3x, we're left with positive x squared. And usually we'll write those 3 numbers with the largest power of x coming first. Okay, and now you'll recognize this as a trinomial. And we can factor this into 2 factors because we have a quadratic. So we look for 2 numbers that multiply to negative 2, the last term, and add to negative 1, the middle term. Those 2 numbers are negative 2 and positive 1. So we'll stick our negative 2 and positive 1 into the brackets, doesn't matter the order. And at the front of the brackets, we need x, because x times x is x squared. So the final factorization is 3x, x plus 1, x minus 2. Question number 94. This time we want to divide and simplify x plus 2 over x minus 4 divided by 2x plus 4 over 8x. So whenever you have to divide 2 fractions, first you can multiply the second by the reciprocal of the second fraction. So you just take the second fraction, flip it upside down, change your dividing to multiplication. And the nice thing about multiplying fractions is that you can just multiply everything across. We're going to multiply x plus 2 and 8x on the top of the first fraction, and x minus 4 and 2x plus 4 on the bottom. So you don't need to look for common denominators. It's nice and easy. We actually don't want to expand these because there might be something that they have in common that they can cancel. So we're going to look at each of these 4 factors and see, are there any numbers that we can take out of the factor? For example, on this bottom right factor, I've got 2x and 4, and both of these are divisible by 2. So I can simplify that by just taking out a 2 and leaving x plus 2. Okay, so that's exactly the same as that bracket there. So I'm still trying to factor as much as I can so that I can see if I have any terms that are in common on the top and the bottom of my fraction. So here I can see that I've got x plus 2 on the top and x plus 2 on the bottom. They cancel, leaving 8x over 2x minus 4. Okay, and both 8 and 2 can be divided by 2. So I'm just going to take a divided by 2, I'm left with 1. 8 divided by 2 is 4. So instead of having 8x over 2, I can also write that as 4x over 1. So in the end, I get 4x over x minus 4. That's the simplest form of the answer. Now for question number 98. We want to simplify these 3 fractions. Okay, and just a little note, in this question, there is no equal sign. It's just an expression. We're not trying to find out what x is. So we can't use the trick of multiplying by the lowest common denominator. Okay, because we can only do that when we can multiply it on both sides of an equation. So we can't use the trick of multiplying by the lowest common denominator. Instead, we need a common denominator for each fraction. Okay, luckily, we aren't going to do expressions anymore after this. So all we're going to do is equations. So you can mostly use the LCD trick, but in this case, we actually need to make common denominators. So x minus 1 is a very different factor from x. These are two very different denominators. But the last one is kind of both of them in disguise. You can take x squared minus x and factor it, because x squared minus x both have a common factor of x. When you take out x, you're left with x minus 1. So it's actually the same as the other two denominators combined. Okay, x times x is x squared, x times negative 1 is negative x. So if we expand this out, we get back to the original denominator. So now in order to make a common denominator, I need to make all the denominators the same. So I need to have all of them having both x and x minus 1. So I need this denominator to have an x, but if I put an x on the bottom, I also have to put an x on the top. I need this denominator to have x and x minus 1, but if I add x minus 1 to the bottom, I also need to do the same on the top of the fraction. Okay, so then I'm left with three fractions, or three terms, that all have the same denominator. Okay, once that happens, then you can combine them all into one single fraction. So once the denominator is the same, you just take that common denominator, put it on the bottom of your fraction, and then on the top, you have your first term plus your second term minus your last term, because this one is minus 1. Okay, and you don't actually want to expand the denominator. You'll always leave the denominator in factored form, but we want to simplify the top of the fraction, the numerator. So let's put that 2 into the brackets. We get x plus 2x minus 2 minus 1. And now we can combine common factors. So we get 3x minus 3 over x times x minus 1. And 3x minus 3 has a common factor as well. So I can take a common term out of 3x plus minus 3. They both can be divided by 3. And then when I divide 3x by 3, I'm left with x. When I divide negative 3 by 3, I'm left with negative 1. So look at that. We've got the same term on the top and the bottom of the fraction. They can cancel. Final answer for this question is 3 over x. Okay, so that's it for Chapter 0. It's not going to be on any test or midterm. It's just some of the skills that we're going to be using throughout the year. Much more importantly is your Chapter 1 questions. And this comes from page 77. Number 28 is, now we're going for solving linear equations. So we have 2 times 13t minus 15 plus 3 times t minus 19 equals 0. Okay, so first thing is we want to expand through the brackets. I'm giving you 26t minus 30 plus 3t. And 3 times 19 is almost the same as 3 times 20, which is 60. So we have to take away 3, so 57. Okay, now we're going to combine our like terms. So 26 plus 3 is 29. And negative 30 minus 57 is negative 87. And that all equals 0. So now we'll put our numbers on one side, keep the constants on the other. or sorry, the variables on the other, and I have 29t is equal to 87. Now I can divide both sides by 29, coefficient of t, and I can figure out what t is. So I get t is 3. Okay, and in this question it also says check your solution. So in order to check, we go all the way back to the original question. And the letter T just means basically a fill in the blank box. So anytime you have a variable, you can treat that as a fill in the blank. And we just want to see if when we fill in the blanks with the number 3, are both sides of the equation actually both the same? Are they equal? So let's take our answer 3 and let's fill it in and see what happens. So 13 times 3 is 39. 39 minus 15 is 24. We get 2 times 24, and plus 3 times 3 minus 19 is negative 16. So we want to check, is that really equal to 0? Sometimes you put a question mark here because you want to know, is it? So 2 times 24 is 48. 3 times 16 is also 48, but since it's negative 16, it'll be negative 48. So 48 minus 48 really is equal to 0. Both sides are 0, so that means that we got the right answer. Okay, question number 32. We want to solve for x. 9x minus 10 equals 5x plus 2 times 2x minus 5. So same steps. We want to expand the brackets first. So you get 9x minus 10 is 5x plus 4x minus 10. Then you want to put all your like terms together. So we get 9x minus 10, 5 plus 4, both of those are x terms, is equal to 9x minus 10. Then we want to put all of our variables on one side. So we're going to bring 9x over to the other side of the equation. And we get 0 minus 10 is equal to negative 10. And then we want to move the numbers to the other side. You can add 10 to both sides, and you get 0 is equal to 0. Okay, so basically you end up with 9x minus 10 equals 9x minus 10, the same thing on both sides of your equation. Okay, which means that it doesn't matter what number you put into x. If you put the number 0, you get negative 10 equals negative 10. If you put the number 1, you get 9 minus 10 is 9 minus 10. No matter what number you put in for x, it's always going to be the same on both sides. 0 equals 0 is always true. So x can be any number. There's infinitely many solutions. Okay, so in order to check this, you can try your favorite number. You can try any number for x, and all of them should work. I like to try really big, crazy numbers like pi or a million. Let's try 100 just this time. So again, x really means fill in the blank box. So I'm going to replace all the x's with fill in the blanks. I'm going to fill in the blanks with my favorite number and see if both sides of the equation are the same. I'm going to choose any number in the world and see if it works. And you could try your favorite number. You could try 0, you could try a billion. You should always get the same thing on both sides of this equation. So 9 times 100 is 900. 900 minus 10, I want to see if that's the same as 5 times 100 plus 2, 2 times 100 minus 5. So 900 minus 10 is 890. 200 minus 5 is 195. So what is 2 times 195 plus 5 500. You get 390. So both sides of the equation are the same. So 100 works. And if you try any other number, it will also work. Okay, so the final answer is that there are infinitely many solutions. Any number will work for x. Question number 38. Here we've got a rational equation. 17 plus y over y plus 32 plus y over y is equal to 100. So in this case, because we have an equal sign, we can multiply the same number on the right and the left, and it won't change the equation. So we want to multiply every term by the lowest common denominator, which in this case is y, because we have y here and y here. So we've got three different terms. We have this term, we have this term, and we have the right side. So everything needs to get multiplied by y. And the really nice thing about that is because on the first term we've got y on the top and y on the bottom, they cancel. Y on the top and y on the bottom cancels. So now those fractions have no y's in them anymore. So we're left with 17 plus y and 32 plus y is equal to 100y. The last y can't cancel because it doesn't have a y in the bottom of the fraction. I don't really need these brackets here, so I'm just adding. So I'm going to combine my like terms. I've got 1y and 1y, which is 2y's, and 17 and 32 is positive 49. Okay, so now I'm going to move all the y's to one side, so I'll subtract 2y on both sides, and I get 49 is equal to 98y. Now I'm going to divide both sides by 98. And so I get y is 49 over 98, which is 0.5 or 1/2. Okay, some people did 98 over 49 and got the answer 2, which is really close. But the correct answer is 49 over 98. So the order that you divide things is very important. So again, we're going to check by going back to the original equation, which is 17 plus whatever answer we got, divided by that answer, plus 32 plus whatever answer we got, divided by that answer, had better equal 100. So we're going to put in the answer that we got of 1/2 into everywhere that we had a y in the original equation, and let's hope that we get 100. So sometimes it helps to do this in decimals. 1/2 is just 0.5. So 17.5 is just 17.5. So we want to do 17.5 divided by 0.5. 32.5 is 32.5 divided by 0.5. This just makes it a little easier to plug into the calculator. Okay, so 17.5. When you divide by 0.5, it turns out it's the same as timesing it by 2. We get 35, which is double 17.5. 32.5, when we divide it by 0.5, it's the same as timesing by 2. We get 65. Is 35 plus 65 really equal to 100? Yes, it is. So it works. And both sides of the equation are the same. And the very last problem, 52. Here we have what looks to be a quadratic. Something squared plus 2x minus 2 equals x plus 1 times x minus 2. So the first thing that we want to do here is expand the brackets. Put the 2 into the bracket and do what we call FOIL here. The first term hits the first, and the outside. The last term hits inside and the last. Okay, and remember that x plus 1 squared is x plus 1 times x plus 1. We can't just put that squared into the brackets. That doesn't work that way. So here I'll expand 2x. 2 times negative 2 is negative 4. X times x is x squared. X times negative 2 is negative 2x. 1 times x is 1x. And 1 times negative 2 is negative 2. So now I'll do the same foiling with the first one. First, outside, inside, last. And x times x is x squared. X times 1 is just x. 1 times x is x. 1 times 1 is 1. So I'm going to get all these terms will just stay the same. And now I'll just combine all the like terms. So on the left side, I've got just 1x squared by itself. And then I have 1, 2, 3, 4 x's. And 1 minus 4 is negative 3. On the right side, I've got 1x squared by himself. I've got negative 2 plus 1 x's, which is negative x. And then I just have this negative 2 by himself. So the first thing I'm going to do here is I'm going to take the x squared onto the left-hand side. What's nice about this is that x squared minus x squared is 0. So because I only have 1x squared on each side, they cancel each other out. Now I'm going to put the x's on one side by themselves. So let me move this x to the other side by doing the opposite operation. And I get 5x minus 3 equals negative 2. Now I'll add the 3 to the other side. And I get 5x is equal to negative 2 plus 3, which is 1. Now divide both sides by 5. And you'll find that x is 1 over 5. Which in decimal notation, 1 divided by 5 is the same as 0.2. Okay, I like fractions the best, but decimals are somewhat easier for checking your answer sometimes. Okay, so to check, we are going to let's put that 0.2 back into the original equation everywhere that we saw x. So I like using decimals for checking, especially when you have a calculator that doesn't do so well with fractions. Sometimes it helps to use the decimal answer. So I'm going to put 0.2 in for x, and hopefully you'll get the same answer on both sides of the equation. So 0.2 plus 1 is 1.2. 1.2 squared is 1.44. 0.2 minus 2 is negative 1.8. Times that by 2, you get negative 3.6. And we want to know, is this going to be equal to the answer we get on the other side? 0.2 plus 1 is 1.2. And 0.2 minus 2 is negative 1.8. So let's see if we get the same thing. So we get negative 2.16 on the left side, and 1.2 times negative 1.8, which is negative 2.16. So both sides are the same. So we know that it works. And that's the end of the solutions to homework set number 1.